So we will be seeing this session on existing techniques and cryptographic algorithms in blockchain for IoT. Um so I have splitted this session into a five split up into five sessions. Like first, we can see how the Bitcoin is evolved and the blockchain technology has evolved. And the second, we can see about blockchain for IoT. Is it essential to integrate blockchain to the IoT technologies? And how the algorithms and what are the existing cryptographic algorithms which we have used in integrating the blockchain with an IoT. And then we can see about the IOTA, and the last topic, we can see about the research aspects to integrate the blockchain with the various domains. So let's start our session with the first topic is the history of Bitcoin. So whenever we see the Bitcoin technology or the Bitcoin word, we come across so many cryptocurrency names nowadays. But the Bitcoin was the initial one, which was introduced by which the idea was introduced by Satoshi Nakamoto in the year 2008. And by the days goes, the by 2009, the live Bitcoin network begins, and the Bitcoin was mined. So initially, the idea was proposed, and this Bitcoin was initiated as a cryptocurrency. And in the live network, the coin was mined for the payment and the transactions. By 2010, this first cryptocurrency stock exchange for trading Bitcoin was launched, and by using this Bitcoin, the stock exchange come forward to use this Bitcoin for their stock exchange purpose. And by 2011, the Bitcoin value was given, like the USD and the rupee values. The Bitcoin value was given as one Bitcoin equal to one USD. And as many stock exchange markets come to use this Bitcoin for various purpose, the value of Bitcoin has also raised to 10 USD by 2013. So when seeing this market range rising by year to year, many organizations come across to adopt this technique to for their organization. So by 2014, Microsoft come forward to accept Bitcoin as a valid transaction for the payment to their organization stock exchange also. And by 2015, the next concept of Ethereum was introduced. So when we are seeing the drawbacks or the what are the concepts which are not available, which cannot be done using this Bitcoin, is it can be used only as a cryptocurrencies, only for the payment or the wallet purpose. We can use this Bitcoin. So the market people come across another concept. When we are giving a logic oriented transaction, it must validate the transactions, and it must use this cryptocurrencies to do some valid transactions. When we are giving a logic, it must validate and do a payment. So that is a concept which was given by the market people. So the Ethereum concept was introduced. So Ethereum will be working by using the smart contracts. So this smart contract is nothing but we will be giving the logic to be satisfied. Once the logic is satisfied, the transactions will be performed by using the Ether's cryptocurrency. So this is a cryptocurrency which is used by this Ethereum platform. So Bitcoin, we are use when we are giving us Bitcoin as a platform. The Bitcoin, the same name we are using as a cryptocurrency. When coming to Ethereum, we are using the Ether as the cryptocurrency. So, and as the Bitcoin is also used for the cryptocurrencies, as well as the smart contract is also in use. And now the Bitcoin value is raised to 2017, and it was the very big deal when Bitcoin was given as 10,000 USD values to this Bitcoin, whereas rupees and USD dollars, this is equally given value for the transaction purpose. And by 2019, the next concept, that is the first edition of Hyperledger, was introduced. So the Hyperledger means when smart contract is given in the Ethereum platform or the Ethereum framework, all the organizations who are in contact with this peer-to-peer network, we can see all the logic or the transactions whichever is performed between the participants who are involved in the network. But and then the organization people come with another concept, that is where, for example, when a software company is having a network, say for example Wipro, Infosys, CTS and TCS are in a network, TCS and CTS want to make a tie-up with some privacy policies and the agreements. So they don't want to give their details about this privacy deal to other software companies. So within the network, the TCS and TCS is making a deal so to make a contract with their mutual connections. So for their contacts, so within the network, they have giving a particular chain or particular contract within themselves. The Hyperledger is introduced. Hyperledger will be used only for the private blockchain, private type of blockchain. So this was introduced in 2018, and now we are integrating the blockchain with other domains like IoT, artificial intelligence, and machine learning. So this is how the evolution of Bitcoin came across by, which was introduced initially by Satoshi Nakamoto. And coming to this, who is Satoshi Nakamoto? And now as blockchain is coming deeper and deeper into many of the domains, we are drilling down to the history of Satoshi Nakamoto, where he lived and where he introduced the Bitcoin when he was in which place he was living, and from where did he get the concept of this Bitcoin and all. And now the research is now suggesting that Satoshi Nakamoto might live in London creating while he is creating a Bitcoin. Um, so coming to this, the Bitcoin is the from where it is evolved. This news is it was concluded by some journal, that is the Genesis block. We will say the first header node will be the Genesis block. So when we are tracking his email or his newspapers readings and all, we can see the chancellor on brink of second bailout for banks. So this was the first news which was introduced by Satoshi Nakamoto in the journal, that is the Times, on the magazine Times, on Jan 3, 2009. So he did not reveal the meaning of this sentence, a chancellor on brink on second bailout for banks. He did not want the Bitcoin to be the one of the currencies like dollars or rupees, which will be decreasing the market price and increasing the market price day to day. He want to change this failure of this economy or the market trade. What are the disadvantages existing in the marketing trade? He have to eradicate those disadvantages or the drawbacks, and for that concept he was introducing the Bitcoin and the many other cryptocurrencies, and he came with an idea of Bitcoin. So days go by, the Bitcoin was introduced, and people says the Bitcoin is a technology and blockchain is a underlying technology, like that. So, but it's not true. Bitcoin works according to the blockchain technology. So that is a true fact. So the Bitcoin is one of the use case or the applications which uses the blockchain technology. So when coming to blockchain, we know that it is a decentralized, distributed, and public digital ledger consisting of the records, which is called as a terms called blocks, which is used to record the transactions across the many computers, so that any block which is tampering the data, it can be retroactively changing the hash value, so that the tampering is not possible when the blocks are distributed, which is shared by the participants present in the network. So this is a main advantage for using this blockchain nowadays. And the Bitcoin is not equal to the blockchain. We know that blockchain is a technology, underlying technology in which the Bitcoin works, and the Ethereum and Hyperledger is also using the blockchain technology. So when we are using this capital B, we are using the underlying technology term. When we say it is in the small Bitcoin, we mean that cryptocurrency is used. So this is the difference when we say the Bitcoin technology or the Bitcoin cryptocurrency. Likewise, the Ethereum and Ether is a cryptocurrency. When we are coming the Hyperledgers, there is no cryptocurrency. We are just sharing the contract or the orderer nodes and the peer nodes, whichever is connected. There is a different concept when we are going for the Hyperledger. And nowadays we can see many number of coins whichever is published in the blockchain research, Litecoin, Namecoin, and we can say Core.db, and also there are so many platforms, so many frameworks have been evolved with this blockchain technology. And then coming to the Bitcoin. So when we are coming to this Bitcoin, we have to know how the peer-to-peer network works. So it is an ad hoc protocol which runs on TCP port 8333. So when when the network is published, we cannot say the sequential range of nodes whichever is connected to the parent node. So here we don't have any sequential topology to be followed. It follows the random topology. Wherever the nodes are there, we will be connecting randomly, and the validation is performed and the mining process continues. So and next point is the every node will be given the equal rights. It will not be differentiated as the parent node or the leaf node or the middle node. Likewise, the rights will not be shared. It will all the nodes whichever is connected to the network will have the equal rights. They all have they will be given the rights for validation and also the changing purpose. Once the data is changed, the duplication of the data is also included in the block with a different hash value. So that is the point where nodes are given at the nodes are given the equal rights, and also the nodes can join at any time and can leave at any time. Whenever it needs to be joined in a network, it can come into the network. If we want to remove from our network, we can also remove it. If we want to respond the network over the nodes which will be orphan, the nodes will be left orphan if it is not responding for more than 3 hours. So this last point is becoming a disadvantage when considering the implementation of blockchain. So once we are implementing a blockchain itself is very computational. It is consuming more power and more storage. So once the nodes are connected, if it is not responding for 3 hours, it is left orphan. So the computational power and the storage which we have used for that particular node is full of waste, and it is consuming the computational power is increasing for validation also, and also the storage power is also increased. So this is becoming a open research challenge nowadays, where we can focus to make if it is not at all responding for, you can make this node to be orphan. Once it is not responding, to be included in the block. Once the new transaction is included, if it is not responding for that particular transaction, you can eliminate the node from the initial stage itself. So this is the open research challenge nowadays, and this is how the peer-to-peer, this is the advantage where the nodes in the peer-to-peer network can work. The next is, for example, I'm having a 7 nodes in my network, and I'm introducing the 8th node, and the 8th node must see whether it is it is familiar with some other nodes which is already present in the network. For example, if 8 is knowing the 5th node, it will be dealing with the 5th node, and the 5th node will give the data to 1 and 7, and this node will be 1 and 7 will give their data to 6 and 3, and once all the other nodes know the new node 8 is joining our network, we will be validating these transactions which the 8th node has present, and all the transactions, all the nodes will have the respective transactions with them. So this is like the flooding algorithm. So like when for example, when we see a friend, when we see a third person from who is working in the familiar college, we will ask our own friend who is working in the same college, do you know the X person who is already present in your college? So we know them, and we made a network. And likewise, our network will be enlarging, and we know some other person, some other Y person in the same college who is in from our native place. Likewise, the flooding algorithm works until all the nodes contacts in our nodes are known in our network. This is an example for this flooding algorithm. Also, it is related to the gossiping algorithm. So when two friends are chatting about the other friend, they will say some gossiping rumors about the third person. This gossiping thing will be sent to the other person. Likewise, the gossiping and the rumors will be spreading to all the nodes whoever is present in our working place. Likewise, the gossiping algorithm is also compared to this Bitcoin live network working. So this is an example, and also how the transaction is working. I am giving the transaction A to B from the third node. I am initiating the transaction A to B. I am the third node, and my A to B transaction is given to 7, and this 7 will be giving the validating this transaction, and it is given to the second one. And from the initial stage, the third node is giving the transaction to 4 and 7, and 7 will be validating, and it will be sending to 2 and 5, and the second node will be validating this A to B transaction. It will be sending it to again to 4, and 4 will be checking whether A to B transaction is already present in my block or not. If it is already having the A to B transaction, it will not be start the validation process. It will say, I am already having this transaction, I don't want to validate, and again I want to added into my block. If it is not validating, and if it is getting some large number of transactions to be validated at the same time, it will be having the transaction to be validated in the transaction pool. So this is how the transaction is flooded into all the network, all the nodes present in the network, and we will be having the transactions in the pool. Once it is validated, it is coming into our block, and once it is validated by all the nodes in the network, it will be packed into a block which is in the blockchain. It is integrated into the chain of the blocks. Okay, so this is a stage where the blockchains are given, and it is initial stage, it is given in the transaction pool. Once it is validated, it is coming into the node, and once it is validated by all the nodes, it will be packed into a block with all the details, where like the Merkle tree, the hash value, nonce value, and the transaction gas value, and all the it is packed into a block, and we will be integrating into our main block. So this is how the transaction works in the Bitcoin live network. So this is how the Bitcoin and the Bitcoin peer-to-peer network works. So coming to the second part, the blockchain and IoT. So when nowadays the Internet of Things, this is a very buzzword we are hearing everywhere. But this IoT was it was initially it was introduced, or it was taken into the place by the Chinese and the European country people. But they have not named it as Internet of Things. They have named as machine-to-machine communication or the distributed computing. Likewise, they were working on different domains, but they have not named it as the Internet of Things. Now, it was collectively named as Internet of Things, and we people have integrating the emerging technologies with the IoT, so that the technologies will be improved with some other devices which we have making nowadays. So what is the need for blockchain and IoT? So there is a question where which is very necessary to integrate blockchain with IoT, and what are the questions to be asked before you integrate blockchain and IoT in your applications. So as we know, the Internet of Things will refer to the system of interrelated or interconnected objects which are able to collect and transfer data over a wireless network without the human intervention. We know major technologies we have using the protocols and all. We will be using LoRa and Bluetooth, Zigbee, and all. So using these technologies, we are transferring the data from one end to the other devices or the connected devices. We use the sensors and actuators, which is the main component of the Internet of Things. Say, for example, I am doing an agriculture project, agri-based IoT. I am giving the moisture level, and when it is coming below the threshold value, I must automatically switch on the motor, and I must supply water to the crops. So this is the thing I want to implement with an agro-based IoT as sensors and actuators component. So when the data is transferred from one devices to the other, that is the humidity level is going below the threshold, is sensed by the sensors which we are using, and the actuators which is used for automatically alerting the motor to be switched on. So when we are transferring the data from the sensors and actuator thing, so in this thing we have to make the data to be a secured one. So if when we are doing a simple applications, we don't need some security aspects. When we are making some complex applications and all, the security aspect is the main thing when the data is transferred from the sensor or the devices connected in the applications we have made. So the security, to mainly address the security issues in our IoT applications, blockchain is the main concept which we need for the addressing the security challenges. So come to the architectures. In the past era, we were using the sensors, large sensors, servers. Servers were used, and the data will be stored in the servers, where whatever may be the applications, the data will be collected and stored in a particular server. Whenever we need it, we retrieve the data. And nowadays, we are depending upon the cloud, whether it is a paid one or the open source one. All the applications we are using, we are making it in the cloud, like Google Photos or Google Docs, Google Spreadsheets, whatever, Google Drive, and all we are using the cloud things. And when we are implementing the blockchain into our IoT or many other applications, every applications will be connected to their then and there, and we will be getting all the informations. Once no other third persons or tampering data is impossible when blockchain is implemented in IoT. But the drawback is the implementation cost, and also the computational power and the storage is very high when we are integrating this IoT and the blockchain. And also the another research challenge we come across is the scalability. Scalability is the main issue where when nodes are connecting, more nodes are connecting in a network. It must already the computational power is very high. When the scalability is coming, large number of nodes are connecting. Even the computational power is coming even more. So that is another issue. So our architecture will be like the future one when the applications are connected with the blockchain and the IoT platforms. So next is the type of blockchain. So coming to this, we know that permissionless, and the other thing is public and private. So there we have categorized as token based and token agnostic. So when you are using only one token, or the only one method is to be used, or the only one contract is to be satisfied, only one logic is to be satisfied, means that comes under the token based. So when the logic oriented blockchains, when we are proceeding with this logic oriented, we can go with Ethereum, next counterparty or the burst coin. When you are going for only the payment or the wallet purpose, you can go with Zcash, Bitcoin, Dash, Monero, or the Litecoin. So this is all collectively called as the token based applications. And when we are coming with the private or permission, in the private network, I have to make our logic to be validated. You can go with Monax. That is another framework. And transaction oriented blockchains, you can go with the Ripple or Rootstock. That is a main thing when there is a very interesting thing when you go for the private networks or permission network. And token agnostic, where the term agnostic is you are making a virtual logic to be satisfied. So, for example, your degree certificate or the diploma certificates are considered as a tokens. And when you are going for registering the marriage certificate, the male and the female persons, a birth certificate must be produced. The birth certificate, if they have crossed the age 18 or 20, when whatever the age we have given, only when the birth certificate is verified, the marriage certificate will be entered, or it can be attached into their own blocks. So that is the two number of threads is increasing. Token based is only one thread will be validated, and they will be executed according to the logic provided. When the multiple threads are given, it comes under the logic called as token agnostic technique. So when you are giving for token agnostic technique in the public network, you can go for Rootstock, and the private network, you can use the Hyperledger Fabric and the multi-chain for transaction oriented blockchains. So these are the two major types when we are going for the types of blockchain, filtering the types of blockchain. So when we are integrating the blockchain with an IoT application, the first thing is you have to see whether my application needs a blockchain. And the second one is what type of blockchain I am going to use. So that is the two main criteria you have to see where before diving into the IoT applications. So what are the questions you need to ask yourself when you are describing the IoT application? So it is necessary to use a blockchain for my IoT application. If we get yes, go with the next question, that is, are there copies of the ledger? If you have yes, you proceed with the next question. That is, redundant copies needed to be distributed in multiple computers? Yes. Do all the IoT entities trust each other? Yes. So if they are trusting each other, so here the problem comes. The second part, the third part, that do all the IoT entities trust each other? They are trusting each other means you can go for traditional database, or bank or government or middleman may manage the data. So because the existing centralized payment or the traditional database is exactly fit when you trust each other or the network participants you are dealing with. So there is no need of blockchain to be integrated with IoT when there is no when they are trusting someone. So blockchain, the main theme of blockchain is trust no one. So when we are not trusting anyone, we can go for the blockchain, and we can have so many copies with among them ourselves, so that no middleman can come. We don't want to trust them. Okay, so this is a question which will be describing need for blockchain in IoT. And next, once you decide the blockchain is very necessary, and next question is, are the IoT devices going to be deployed in a restricted network? If you get yes, you have to say whether the people who are updating the network is restricted or not. If you are going to give a very restricted people to maintain or update, you have to go with the public or private. You have to mention the filter the types of blockchain you are going to use. So when you are going to deploy in a restricted network, yes, you have to give the question who can update and maintain the blockchain. If it is no, you have to give in there also you have to give for public permission, public permission less. Here you can give for private permission or private permission less. So this is how the blockchain with the integration of IoT goes. And then I'm a very beginner of this blockchain. I have to sharpen my blockchain chains. If you are very curious to learn about this blockchain chains skills, you can go with IBM Academy. So here I will be pasting this link into the chat box also. You can go there, and if you are having the organizational mail ID, you can go with into this academic and home. If you are not having the organizational mail ID, you can fill this form. They will be providing you the credentials, and with those credentials you can go with this blockchain materials and you can learn more about that. And next we can see about this some usable link. uh, Metamask.io. So I have already created. Open this, it will be displaying like no Ethereum provider detector, install a web enabled wallet. So once you have the extension of MetaMask, I'm giving the MetaMask enable. So you can see the MetaMask interface. So I'm requesting 1 Ether from first set. So you can see the transaction here. When and another time I'm having the requesting, it's displaying some error. That is the replacement transaction under price. So they will be giving some limit value, limited gas value. Under that you can get the some free ethers, and using that ethers you can transfer. You can do the transactions based on the value you already having in the wallet. So to see this. So I am connected to this Robston test network. So you can connect to any network, that is Ethereum, POV1, RINs by sample localhost. So when account details, going for this account details or the expand. So I'm not getting this ether. So the activity is I have got 3 ethers when I am connected to this Robston test network. So the same detail you can see with the etherscan.io. So when you go for etherscan.io, the second link which I am pasted here is etherscan.io. Here when you are connected to this Robston network, Robston test network, you can see here you can copy your account, and then you can read the scan. This is called, so you can paste here. Here you can see I have got 3 ethers when I am connected to this Robston test network. And similarly, when you change this network, Ethereum mainnet or Ethereum, I have not got any ether, so the value will be changing to this 0. This is Ethereum, and when you are pasting your account, 0 ethers. Likewise, this is a website where you can get a free ethers to work on the transactions. Whichever you have, you can request for 1 ether, 10 ether, and 100 ethers. So this is a useful links where you can see the free ethers and to work on. And the next one is plock.com products hash calculator. So coming to the cryptographic algorithms, the hash value plays a main role where the algorithms differ about the hash value, SHA-256, SHA-256D, and the hash value will be changing. So when go this here, so online hash calculator. So here when you are giving some string, calculate the string hash value. So you can see whatever the string you get here, you can see the MD2, MD4, MD5, SHA1, SHA224, SHA256, whatever the hash value you need, you can copy this hash value and paste it there. So this is a thing where you can learn about the hash values, whichever is calculated for the particular string you are providing. You can provide the file also, the hex bytes also you can give. For the particular string, you can see the various hash values we are using in the cryptographic algorithms. And here you can see the blockchain demo.io. Here you can visualize that. So here I'm having the Genesis block. So the Genesis block, generally we have the previous hash value will be 0, and here the one peer, that is Satoshi, is there. If you want to add more peers, you can add some more people. Oreo and adding peer will be getting some more people. And here the initially the Genesis block will be present. It does not have any previous hash value, and I'm adding some block, adding new block. I'm getting the hash value is 00DC. Here the particular respective hash value is 00DC. Here you can see the previous hash value 00DC. This is how the blocks will be connected and how the hash will be generated. Even if you are changing this one, the hash value will be changing. Likewise, you can mine this block. I have wrongly deployed this data. I have to mine another one time. So you can mine this, according to that hash value will be changed, and another one time it will be mined. So likewise, adding block works. You can see here, this is for only one network of this Satoshi Nakamoto, and you can add peers. You can get some more blocks here, another Genesis block, and you can add some more blocks here. So these will be connected, adding peers to the network. Likewise, you can see this blockchain demo. And also another one thing I have to show, another one link is tools.superdatascience.com, that blockchain tokens. Here you can see how the hash value, here you can separately calculate how the hash value will be calculated, or the blocks, how the blocks look, block header, nonce value, data, and the hash. I can bind the data whatever I am giving, and the blockchains. Here the blockchains will be there. So here you can see previous hash value, and the hash value will be mined. Distributed one. Distributed one, they're the same thing we have seen, the peer A, peer B, and peer C. Likewise, we can given this. Here the tokens value. Tokens are given. Whenever the nonce is nothing but the magical number, it is created randomly for every block whichever is created by us. So when you are changing this, I am changing 106 to 56. 56.44, and I'm giving the mine value. The nonce value will be changed. So you cannot tamper without the knowledge of other persons. They all will be know whatever the data will be whatever the data are changed. So this is another platform where you can see the demo. The next is cryptographic algorithms in blockchain-based IoT. So here, coming to the, we have seen the hash algorithms and hash, what are the hash values we have studied in the cryptographic algorithms. Mainly in blockchain-based IoT, we are using the elliptic curve algorithms. So coming to this, why we are going for this elliptic curve cryptographic algorithm is IoT is majorly used in the constraint network. That is a constraint sensor network which will be having very small key size. So when you are considering the small key size, the elliptic algorithm will be better when compared to the RSA algorithm, Diffie-Hellman or RSA algorithm. Comparing to that, for a constrained networks, we can use the elliptic curve cryptography technique. So the public key cryptography is essential for providing the security and privacy in blockchain. However, this resource constrained devices will be struggling to make some power. So the sensors and it will be very much struggling to consume that power. Mainly when integrating this blockchain, we have the challenge of this computational power and the storage. So even small devices will be struggling to make that tackle that power, or the consuming that power will be a very challenging one. So the computing requirements of modern secure cryptographic schemes. So we are going for this elliptic cryptography. When we are deploying this RSA algorithm, it is very slow and power consuming when implemented on IoT devices. So the right cryptographic scheme should be taken into account not only on the computational node and the memory requirements, but storage must also be considered. Next is the common public key based cipher suits or RSA and elliptic curve Diffie-Hellman key exchange are the ones which we are recommended by the National Institute of Standards and Technology for the transport layer security. So this RSA based cipher suits use this RSA as a key exchange algorithm, while the ephemeral elliptic curve or the Diffie-Hellman key exchange based on use an algorithm makes use of this ephemeral Diffie-Hellman based on elliptic curves. So this currently the RSA key size are not practical for most of the IoT size, as this 768-bit and 1024-bit RSA implementation were broken in 2010, and 2048-bit key is the minimum size considered to be a secure. But these bit keys which are not at all practical to be implemented with the IoT devices. So then we are going for this elliptic curve cryptography. Okay, so use of this 2048-bit certificates on an ephemeral key exchange algorithm introduces heavy overhead and computing requirements, which are very difficult to accommodate on the constrained hardware capabilities of most IoT nodes. And then we are going into the elliptic curve cryptography. So this represents a much lighter alternative to RSA. When implemented on resource constrained devices, ECC outperforms RSA in terms of speed and power consumption. So in August 15, the National Security Agency recommended to stop using Oxford B, and ECC-based algorithm was deployed for the quantum cryptography. And also one more update on this quantum cryptography is 2 days before, the professor from IIT has come up with this a new technique, cryptographic algorithm based on the Diffie-Hellman key exchange also. The Diffie-Hellman key exchange, how it works is we will be signing with this public key, private key and all. The concept we know with the Diffie-Hellman. She has come up with a technique there. Without opening the lock, we can encrypt or we can decrypt we decrypt the message which was sent by the other opposite side. Yes, that was a technique which was used by, which is very much useful when you are deploying the technique in quantum cryptography. The techniques which were used in the existing method, we will say that for computing this message or to decrypting the private key or finding the private key will be taking so much years to compute for this normal computers which we are using. But when we are going into the quantum era, it will be find out in a very computed time or reputed time, we can make this key to be available to the public. So the time to finding the private key or decrypting the message will be reduced. To overcome that, the IIT professor has come up with some other technique which was using without decrypting or without disclosing the message. You can read the message from the user B, and which is sent by the user A. So that was a new concept, new update on quantum cryptography. And then elliptic curve, when coming to this elliptic curve, which is represented by EP of A comma B, where P is the prime number and B is restricted to mod P. And this elliptic curve are not ellipse, but the equation defines the calculation of circumference of ellipse. So we have represented as P plus 1 minus 2, that is root P less than equal to N. It will be on both sides, less than or equal to the N. So this is an curve which is y is equal to q square root of x cube plus ax plus b. Come to the types of elliptic curve. So here you can see the symmetric type. When you are joining this two curves, you can have the equal halves on both sides. There is left and the x-axis and y-axis. You will get the symmetric elliptic curve. So that is the main advantage when we are plotting the points on ellipse. So that's why the elliptic cryptographic is main advantage when you are getting the private key from the public key. So the singular elliptic curve is 4aq plus 27b square equal to 0. It is defined as a singular elliptic curve, but the three distinct roots are not possible if we are using the singular elliptic curve. When you are going with a non-singular elliptic curve, it must not be equal to 0. The three distinct roots are possible, and so the formation of abelian group is possible. We know that abelian group will comprises of commutative. We will have the sum product of these three terms, A of B of C equal to, and we have the product will be the same on both sides. That is the abelian group property must be satisfied when we are going with this non-singular elliptic curve type. And the terminologies which we are using the elliptic curve is affine points, or the points whichever is plotted on the elliptic curve, and this O point we denotes that it becomes the infinity, where P plus or minus P, where we are having some value, and the negation of this value when you are combining these two, it will be becoming some infinity, and it can be defined as EC over ZP and EC over GF of 2 power m, can be used for the key exchange and the encryption purpose. So this is nothing but the abelian group is satisfying the abelian group properties. So coming to the encryption and decryption, global public elements will be EQ of A comma B. This is an elliptic curve with the parameters A, B and Q. Q is the prime number and G is the point on an elliptic curve whose order is large value n. And user A key generation is we are getting the NA as a private key, NA is less than N, and public key PA is equal to NA into G, and user B is key generation. The same terms will be used with the suffix B, and the calculation of secret key by user A is K is equal to NA into PB. Secret key by PB is K is equal to NB into PB. So this is how the encryption and decryption process goes. And then first we have to find the points on the ellipse. So we are having E11 of 1 comma 6. So here P is equal to 11, A is equal to 1 and B is equal to 6. P is equal to X plus X plus B mod 11. So substituting this value, we will get some table of values. So we have to see the points which are equal to LHS and the RHS. So the terms are, if we are having 5 for 2 and here also for Y you are having for 7. So this 2 and 7 will make a pair of points which can be plotted on the ellipse. Likewise, you have to combine the points which are having the same value on LHS. So this finding these points, you get 2 comma 4, 2 comma 7, 3 comma 5, 3 comma 6. Likewise, you will be finding the points which will be lying on the ellipse. When exchanging the messages, the set of points will be given, and from this point you have to calculate them KB and KPB. So coming to this encryption, you have to first the term is encryption CM. You are calculating the ciphertext KG comma PM plus KPB. So first we have to compute this KG. KG is nothing but XR comma YR. So with this, with the help of these points, that is G is equal to 2 comma 7. Here you have to consider XP, YP, XP is 2 and YP is 2, and also XQ is 2, YQ is 2. So computing this one, that is the and this equal to 3x square plus 8 divided by 2 YP mod 11. And for XR, you have to calculate from the value which we have calculated from this formula. You have to substitute this minus XP minus XQ minus K. Here the 2 points are same. 2 comma 7 is XP, YP, XQ, YQ. So with this calculation, you can compute this computation of KG. And the next one is you have to calculate PB. PB is equal to NB into G, and you are given this G. There is a G 2G plus G. So 3G you have split it into 2G plus G, and the value calculated from these two formulas are 8 comma 3. When you are substituting this value, you will get 8 comma 3. So here you will be getting PB is equal to 8 comma 3, and computation of KPB is 7 comma 9. So you are just integrating this formula, and it is 2 comma 7 and 5 comma 9. You are having 7 comma 9 as a KPB, and you have the last part is PM plus KPB is 10 comma 2. The ciphertext will be 5 comma 2 and 10 comma 2 will be the final ciphertext. And next, this is the main part where the private key is computed from the public key. Decryption will be carried over the same formula with the negation, that is minus NB of KG. In general, when we are given the points 2 comma 4, the private key, the 4 is the public key, so the corresponding private key will be minus 4, since it is a symmetric one. But the negation, it is not considered. When you are giving for the modulo 13, apply the modulus P value on modulus 13 plus of minus 4 equal to 9. So from inverse, you can get the 9. So from the private key, from the public key, you are computing the private key. That is, the private key is 9, which is corresponding for the public key 4. So likewise, the private key is computed from the public key. And next is the blockchain hash functions. So these hash functions, when it is applied for this coin, Bitcoin or the other coins, whichever is introduced nowadays, the first thing is SHA-256D. It was used by Bitcoin, peer coin or name coin. So this D represents nothing but the data which is varied when you are changing the data, the hash value is automatically changed. So that is the thing which D represents, SHA-256D. And SHA-256 was used by Shift coin or MR coin and script by Litecoin, Gridcoin or Dogecoin. So this hash functions are also a key in a blockchain-based system as it is required to sign the transactions. So for hash functions for IoT applications have to be secure. It must not generate the collisions. For one devices, when it is given by the ID, when it is connected to a network, it must not collide with the other network. We will be seeing that one to one, one to many. Likewise, it must not make a collisions when the hash functions are given for the IoT applications. It must consume the small possible amount of energy. And also this SHA-256 is more efficient to make use of the advanced encryption standard. So AES is more efficient, and further research is also going on with this real blockchain based IoT application. And the next one is IOTA. So this is a platform or the open source distributed ledger which is mainly designed for the IoT blockchain based IoT applications. It is not a blockchain. It is blockchain based IoT applications. You can see the ledger based transactions. You can see the transactions one by one and how it is connected to a network. You can see with the help of this IOTA. It is also known as a cryptocurrency which is designed for the IoT applications. So it is generally called as a protocol for IoT. It is a scalable distributed ledger and it is considered as an open source. It's a trust layer. It is not as a blockchain. Individual transactions are tangled together. Tangled in the sense it is twisted into a mass. Okay, so the tangling is done by using the directed acyclic graph, that is that which we will study in the data structures for connecting the transactions. So the advantages are self-regulating, very scalable, and it is a non-profit organization which is performing these functions. So for example, when you are using this so this is a link where you can see the visualization of the transactions, how the transactions are coming in and out. So I'm decreasing the transaction to only one transaction, and the transaction rate is 0.1. And I'm increasing the transaction. I'm having the 5 transactions, but the transaction rate is 0.1. So when the transaction rate is very low, you will be having a single chain. So that when the new transaction is coming 5, there is no way it must be approve the transaction code. So there is no other go. It must approve only one transaction. It cannot pick up any other transaction. So that is a very drawback of this IOTA. When the transaction rate is very low, I am increasing the transaction rate. So now the transactions are increased. The number of transaction is also increased. So okay. So when we are considering 29, so it can approve the transaction 23, 25 or 26. So it can randomly pick the previous transactions in a DAG. It can randomly choose their own option to be approved by the approved by 29. So this is a thing where you have to focus the IoT devices when it is tangled together. It can approve the transactions or the values whichever is measured by the sensor or actuators. You can give whichever is to be connected with the previous values computed by the sensors also. So this is for a uniform random transaction. So this is the IOTA first concept of this IOTA. So here you are having 6 and the 6 we can approve 5, 4 or 3. Okay, so this is a DAG example. So tangle, which is nothing but a data structure behind IOTA, a particular kind of directed graph which holds the transaction. So each transaction is represented as a vertex. When a new transaction joins a tangle, it chooses two previous transactions to be approved. So it adds 2 new edges to the graph. So in this example, we can see the 5 approves 2 and 3. So transactions are the informations of the form. Person A gave person B 10 iotas. Likewise, the informations are given as a transactions here. And the next one is the term is tips. So the tips is nothing but the new transaction whichever is not approved by any other transaction. So here you can see the six is called as a tips. It is not approved by any other transaction. It is coming into the network. It is approving the previous transactions which is already present in the network. So these are called as the tips. Each incoming transaction need to choose two tips to approve. At least there must be two tips. If there is not, the transaction rate is very low. So the strategy for choosing which two tips to approve is the IOTA's NIP technology. So the simplest strategy is uniform random tip selection. So each incoming transaction looks at all the currently unapproved transaction and simply chooses two at random. So randomness is so the transactions we have some periods are busier than others. When we are having transaction rates are high, many other nodes are increasing and you can choose many nodes whichever is not approved by any other nodes. You can have a cycle or you can form a DAG which transactions are not approved by previous one. It can be achieved by the Poisson point process model. So here we can use this model by to make an example like how many customers walk into the store in a given time period. It can be many persons can cross the store in the morning, or it can in the evening. It can be very low in the morning time or working peak hours. The more persons will not be coming into the shopping complex. So in during weekdays, it can be a peak one. So likewise, you can measure how you can count how many customers walk into the store in a given time. And also the number of phone calls made to a call center. So and then the when you are having transaction 4, 5, 6 you are having, and after that the transaction 7. So after that there is a long pass. The transaction 6. After there is a long pass, the transaction 7 is coming. So on an average, the rate of incoming transaction is constant and it is set by a number lambda. So the lambda is nothing but how many times number of transactions, the speed by which the transaction come into a network. Likewise, the time unit can be calculated. And then if the lambda is very small, we get a chain. So we have seen that when a new transaction is coming, it has no other choice to get with the previous 10. It can approve only the 10th transaction only. So it is coming, transaction is very slow in coming and it is only one single tip to approve. When the transaction rate, the lambda is very high, the number of transactions will be high, but the genesis or the head parent transaction will be the only one for all the unapproved transaction to have the approved. And the next is randomness of transaction. We have each transaction is invisible for a certain period after it arrives. For to overcome this, we are making the transaction, whatever the approved transaction, we are making it is a invisible one, so that the incoming new transaction will be approving the transaction whichever is already present in an unapproved state. So that is the thing we are overcoming this long range and the short range of number of transaction rate. So here you are represented by H. Okay, so this brings the triangle closer to the real world, where it takes some time for people to tell each other about the new transactions. So next is unweighted random walk. So here you can see the weighted like Markov model, there will be a probability will be given. So when three transactions are given in a time. Okay, here you can see that I can see the log details also. Here they have given the weight of the transaction to be approved. So here when one first transaction is weight is 3. So that is the probability weight.
லாகின் பண்ணுங்க எக்கோ அடிக்குது நான் பேசுறது இது லாகின் பண்ணுங்க மெயில் நான் வரேன்
So based on the probability, we can make the approved transaction to work according to the weights or the nodes whichever is attached to the previous node. So that is the thing where the unweighted random walk. So this overcoming the drawback in the previous uniform random chip transactions. So next is the lazy tips. Lazy tips is nothing but when a new transaction is coming, it is not approving the previous transaction. It is approving the genesis transactions or the some other transactions in the network. For example, when you are giving the 14th block as a 14th transaction as a new transaction, it is not approving 11, 12 or 13. It is just approving 0, 1, 3. So this is a lazy tip example where it is not approving the recent transaction to be validated. So using this unweighted route, this bad behavior is even encouraged. So this is about the IOTA, which is made for the blockchain platform. And the last part is research aspects of blockchain and IoT. So when you are integrating with the IoT comprises of many technologies, machine learning, big data analytics, or the big data analytics, or the artificial intelligence. So according to this, when you are integrating with the blockchain, nowadays many research is going, and we can see some of the researches whichever is covered with this blockchain technologies. So the IoT is an emerging of our engineered physical environment with information system to create smart adaptive objects and environment. So here the devices whichever is connected to each other is increasing day by day, and it is connecting 26 billion devices by 2020 CutNet prediction. So according to that, we are also increasing the devices day by day. This devices can provide an automated and transaction infrastructure for next generation operating systems. So here you can see the application in blockchain and IoT, which was given by SLOC, that is SLOC safety lock. Is it audible?
Ma'am, it is audible, ma'am. Ma'am, please
Yes.
continue, ma'am.
Yes.
Hi, my name is Crystal. And I'm Stefan. I'm Sam. We're here in London. First IoT with blockchain hackathon using Slockit. Slockit is the first physical implementation of blockchain technology. We think it's going to revolutionize the emerging sharing economy. But let us show you how it works. Slockit makes smart contracts useful by making them enforceable. A simple example is a humble lock, a slot. A slot can be used as an Ethereum contract to open anything. For example, this lock-powered door can provide access to an office or rental apartment. These devices are coordinated by our first product, the Ethereum computer. Slockit is generating a wide range of technologies embedded in any smart contract. Individuals and corporations will be able to rent out bikes, issue insurance, and receive payment in one single step without being at the mercy of hackers or centralized payment providers. Individuals with Slockit-enabled electronic locks will be able to accept reservations via the blockchain, which deals out in the and Slockit-enabled digital padlocks make it possible to rent or send anything secured by a lock. And the transparency, auditability, and security properties brought on by the blockchain. There's more. Slockit is also a platform for developers. Because it works with Raspberry Pi,
Yadusita, ma'am.
Beatable, and even with a tiny Kindle Odyssey, many developers can build applications.
Ma'am?
Oh, yes, ma'am.
Ma'am, actually, it's not clear. It's audible, but it's not actually clear, ma'am. We can't understand the conversation, actually.
Okay, okay, ma'am. Okay, I will
Okay.
explain the concept.
Okay, ma'am. Okay, ma'am.
But the vision is somewhat more for your interest in slot games. It's very important for us to get your feedback and help shape the future of the product.
Okay, so the concept is we are making the Ethereum, that is a smart contract concept. Only when your Bluetooth connected phone is brought into the in contact with the sensor which is attached to the lock, it will be opening. So this is a safe lock. So that is a concept behind this safety lock. So the Bluetooth with your phone is connected to the smart contract, the blockchain integrated with the lock. And once your Bluetooth connected phone is connected to the sensor attached to the lock will be open. Otherwise, it will not be open. So this is a concept behind this lock, automatic lock system using the smart contract. So this is first application in IoT, and now IBM is getting into the blockchain for improving the things with the Internet of Things and blockchain. And now it is termed as cognitive Internet of Things. So it will be a combination of AI, IoT, and blockchain, which will be more interesting across the industries and made it possible IoT applications. With this, we are adding some play with whatever the technologies we have used, machine learning or the artificial intelligence, we are integrating with the blockchain and getting some more security platforms. So it is giving some examples for complex trade, links, and logistics, whereby smart contracts can follow via blockchain technologies register. There is everything that has happened to individual items and packages. So the logistics is main thing where the blockchain can help to learn about the how the smart contracts and all works. So for example, I can show the another example also. For example, in your house, in the refrigerators, when you are integrating the sensors in your refrigerator with the smart contract, and when you are not having some vegetables, if your carrot is not present in your refrigerator, this will be alerting you in the phone when you are crossing the supermarket. You don't have carrot in your house, you want to buy carrot from the supermarket. So there is a very fine thing, the logistic platform, where you can combine the smart contract, IoT, blockchain, artificial intelligence, and also this is a basic example where you can make IoT applications with the blockchain. Next is future of blockchain. According to this International Data Corporation, the IoT, blockchain, and cognitive computing, which will be the three pillars of ERP. So this is a statement given by this Gutter prediction and all, and the blockchain plus big data. So when the IoT is coming into a picture, we get lots and lots of data, whichever is collected, whichever is generated day by day. So this data must be a very secure one. So the blockchain is integrated. So automatically the big data analytics will be coming into the picture. So this decentralization is a major thing for blockchain, and the big data, we see the three V's: velocity, veracity, variety, values, and all. So the three V's is now emerging into the five V's. That is veracity and value of the data, whether it is a noisy data, raw data, or value data. We have to recognize that. So the data exchange they have given us 75% of business data remains unused for data analytics. So the data analytics also coming into picture, and with that you can integrate this security purpose for the blockchain also. So when you are comparing the benefits, the blockchain is having the benefits of decentralization, flexibility, transparent, and security. Big data will be enhance productivity. You can predict your profit loss for the organization, saving the time and cost, improving the decision making, better customer services also. And next, when you are comparing, when you are getting into the blockchain and big data analytics, the big data applications is using the pattern recognition task from thousands to millions of blockchain interactions to identify the fraud users and bad users. So when coming to blockchain, the network participants, when their profile is given, the participants when entering into the network using the pattern rec- pattern recognition, you can analyze whether they are fraud users or the bad users. So with this, you can make use of the big data analytics. At the same time, this blockchain can be grouped and classified to access the banks, operators, and financial services and trustworthiness. So it will be majorly useful for the payment system, which will be deployed in a short time. And also, when you are seeing the real-time initiatives taken by this blockchain and big data is the TAILS, Aerospace Organization, which was initiated blockchain for complying the NATO standards, not Atlantic Treaty Organization standards. For they have deployed this blockchain with the aerospace for all the organizations, even every departments under this aerospace, they have implemented the blockchain for if a passenger is booking a ticket for their journey in December, and the next December there will be recommended system we will usually have in our mobile phones. You have wished someone in this day, do you want to wish her in the same year? If you want to have some invitations, likewise the recommended system or the reminder system, likewise they have implemented in every department. Even the logistics departments in aerospace have implemented the blockchain initiatives with the big data. It was implemented in November 2020.
A French multinational company specializing in products and services for aerospace and defense industries, is using blockchain technology for a new management system at its production hub in Spain. According to an official announcement on November 5th, Aicte is seeking to deploy technologies like blockchain and big data to enable the digital transformation of its defense and aeronautics-focused production and maintenance center. As part of the initiative, the Paris-based company looks to comply with standards by the NATO and defense authorities by using blockchain to increase traceability of processes at the center. The announcement reads, according to the announcement, blockchain will be part of a new management system connecting with all the applications that are currently used on its network. The new platform is expected to efficiently connect all processes, improve communication with customers as well as maintenance operations. Radio communication, aeronautical and naval equipment are among the products that will have this new management system, the announcement notes. Thales has been experimenting with blockchain to boost its operations in recent years. In 2018, it partnered with major consultancy firm Accenture to upgrade aircraft supply chains using blockchain. Thales did not immediately respond to Cointelegraph's request for comment.
So this is the thing where the logistics application is coming to practice with the aerospace department. So the things, whatever the materials which were given for the exporting, importing, what are the conditions of the goods, whether it is arrived safely or not, each and every attributes or the each and every details of the particular goods we can analyze using this big data or the blockchain initiatives. So, and then the blockchain and machine learning. So, we have come across many algorithms in the machine learning, support vector machines, clustering, bagging, deep learning algorithms such as convolutional neural networks and long short-term memory can be used to analyze the attacks whichever used in blockchain-based network. And also, there are few attacks which is not yet addressed in the blockchain-based network also. There is a 51% attack and double spending, and also these are the attacks which is still need some solutions to be answered for the blockchain based network. So here there you can use the blockchain machine learning algorithms to address such issues. So we're coming with the architectures, the sensors and smart devices whichever is using the day-to-day life will be in the bottom layer, and the devices whichever is uh, this will be connected to the process which we are using for the applications. The smart applications whatever we are using in the devices will be the second layer, and the user will be using this application, and based on the machine learning model, the data analytics or the real-time analytics based on the algorithms you have deployed in the machine learning model, it will be deployed in the blockchain, and this blockchain will be connecting the users, whoever will have the access to use the applications which you have used in already in your mobile phones. This sensors what mainly the authorized persons, who are the authorized person to be connected with the sensor are the smart devices or the IoT applications whatever the deployed in your smartphone. So here the blockchain will be implemented between the machine learning model you are deploying and the applications whichever is already deployed in your smartphones or the IoT devices. So this is an architecture based ML adoption and BC based smart applications. And when you are coming to this ML adoption, you can filter into four categories: goal oriented, layer oriented, countermeasures, or smart applications. Goal oriented in the sense you can make use of the proximity sensors when you are using that object detection. When you are getting some phone, you will be answering your call, the light switch is off. So there is a proximity sensor used in your mobile phones. So goal detection, monitoring, detection or monitoring, prediction, response or prevention. These are categorized into goal oriented. Layer oriented, whether you are going to focus on some particular area particular layer, application layer, endpoint process, or the users. And the countermeasures, analytical part or the real-time part. You're getting the data for the analytical or the real-time applications. And then for smart applications, whatever you are using, the smart city applications or the customer services, energy and utilities, product manufacturing, or the device personalization. So these are the areas where you can adopt this ML adoption. So the future research can be focusing on the memory part, infrastructure part, suitability, privacy, quantum resilience, security, and implementation part. So these are the open challenges where you can make use of the ML algorithms. So AI and blockchain. So here you are having some interesting open source lab. If you want to make use of AI integrated with the blockchain, they are giving a Cortex lab. So it is named as Cortex, which is an open source where you can work when you are integrating AI with the blockchain. For example, as previously said, when you are going, when you are crossing the supermarket, the machine learning model or the smart contracts, which is implemented in the refrigerator, will be saying what are the lack of vegetables you don't have in your house, you can buy here. So here you must be connected to the supermarket and the car must cross the supermarket. But here, when you are implementing AI and blockchain, this AI will be automatically connected to the big basket or the some other commercial websites, whichever is connected with this AI technique. It will be automatically ordering the things whichever is not present in your refrigerator. So that is a beautiful and wonderful thing when you are connecting AI and the blockchain to the uh, technique. So when you are seeing this, you can see how the AI and blockchain is connected.
Blockchain started with Bitcoin, a decentralized digital currency based on distributed ledger technology. Then entered Ethereum, which allowed developers to write programs, smart contracts, on top of what Bitcoin blockchain provides. Now, meet Cortex, the future of blockchain technology. Cortex adds artificial intelligence to traditional smart contracts, making them truly smart. How does Cortex do that? On the one hand, Cortex takes an AI model trained by AI developers and stores it on the storage layer of the Cortex blockchain. On the other hand, the design of the Cortex virtual machine gives the CPU's job to the GPU or the FPGA, making it AI ready. App developer can then access and execute these AI models by paying CTXC, the Cortex native token. Let's say Johnny has trained an AI model for facial recognition. He submits it to the Cortex storage layer. Meanwhile, Amy, who is writing a decentralized payment app, can use this model in her app to verify users, and she pays Johnny and CTXC each time the model is used. Such an infrastructure will rebuild the AI on blockchain ecosystem in a big way. App developers pay and sustain AI developers, while AI developers are incentivized to provide more quality AI models to app developers, creating an ecosystem that leads to the evolution of better and better AI models. Good AI models will no longer be monopolized by big corporations, but are distributed on the Cortex blockchain. To illustrate the difference between Bitcoin, Ethereum, and Cortex, imagine that you are the owner of a grocery store. With Bitcoin, you have to manually check if the right amount of payment has arrived. With Ethereum, you can bind all your goods to smart contracts. When goods are taken out of your store, you can be assured that you will be properly paid. With Cortex, you don't even have to be at the store. The AI models enabled by Cortex would recognize every item in the basket and even the customer's face, providing a checkout-free shopping experience for both the owner and the customer. This is just the tip of the iceberg. One of the many AI-powered decentralized applications that will be implemented on Cortex to transform our lives for the better. The only limit to what can be achieved Cortex is your imagination.
So yes, this Cortex will be a very good platform when whoever is integrating this AI with the blockchain can use the lab to integrate many machine learning models to come across with. Yes, so that's all from my side. Thank you for listening and thank you for your patience. Hello.
Ma'am?
Yes,
Thank
ma'am.
you. Thank you, ma'am. Participants, if you have any queries, please put it in the chat box. And there is one question in the chat box, man. Mr. Simi
Nice.
Moy, how access control in IoT with
So
blockchain can
access
be moved?
control, access control when you are controlling the sensors or actuators, Aman. I'm not getting the clear question.
Simi Moy is authorization. He is asking for
Authorization.
authorization. Yes, ma'am.
Yes, that is by means of this IOTA. So when you are approving the transactions, like how the blockchain works. So when once it is transactions are validated by all the users in a network, it will be packed into a block. So the same concept will be given into the IOTA. So when the transaction is coming into a network, when a data is coming into the network, the data must be approved by all other previous nodes present in the network. So that is how the authorization coming to the IoT and blockchain. So that is how the IOTA visualization shows.
Participants, any more queries?
So thank you, ma'am.
Thank you, ma'am. Thank you, ma'am.
Your
Come on,
most
Ms. Madam.
exciting talk on blockchain will be useful for every participant. It was really an exciting section, ma'am. We are sure that all participants would have attained good knowledge on cryptographic techniques in blockchain for IoT. Once again, we thank you for your valuable inputs, ma'am. We are eagerly looking forward for more such interaction in years to come. Thank you.
Thank you, ma'am. Thank you so much for giving me this opportunity, and also thank you all the participants for listening and for your patience to listen. Thank you. Thank you.
Thank you, ma'am. Participants, the feedback link has been posted in the chat box. Kindly fill it. We'll meet tomorrow at 10 a.m. Thank you.